Good afternoon, Matt. Just gone past 12.
Perfect. Are we live, I'm guessing?
We are live today.
I was enjoying the beautiful banner, so you surprised me.
Yeah, Matt and I were just chatting about whether or not we should have the intro countdown video, and we thought we'd just pop up the banner and we try something different this week. Hi Matt, welcome back again. Your shed is looking good.
Yeah, the cabin's looking really good. I was going to say on that, let us know if an awkward pause when we when we're staring at the screen is nicer than a countdown. I'd be interested to see what people think. I think the countdown gives good warning. You can join the stream within the 30 seconds and not miss anything. But at the same time, I'm a little aware. It's what's happening? I'm not too sure. You don't know what it's counting down to, maybe. So yeah, let us know. I was going to say as well, depending on where you are, Paul and myself are still in Melbourne, still in the same location, but we'd be interested to see where everyone is across the world. And yeah, cabin's going fine, Paul. I have a delivery tomorrow with a lot of the inside stuff coming, so I'll build that out and hopefully make it a bit more pretty than it is. But it's a really nice working space and it keeps warm really well.
Yeah. Well, for anybody that is new to the stream, Matt and I both work for AWS. Matt's a principal TAM, which is a technical account manager, and I'm a solution architect. And our show is talking about and demonstrating new pieces that come out with AWS, and just touching different pieces of technology that you might not see on the mainstream blogs, and diving a little bit deeper based on what the audience has requested and what we think is, might be relevant or fun to go ahead and work with. And today we're going back to, I guess, the roots of the shed and the idea of getting outside and connecting some wires together and touching some tools and so forth. So we've got a show today about if you had something at home and you wanted to expose it to the internet, what's a mechanism to go ahead and do that. And I've got a bit of a, let's say, a bit of a crazy solution where I went ahead and built something out to do that, and I'll take us all through that.
Yeah, no, that sounds really fun. It builds on top of what we've covered in the past, right?
Yeah, that's exactly right.
Yeah.
So it'd be good, just quickly from the audience, before we have a look at Grow Like a Taco's question. Where's everybody from? Do we have people from outside of Australia? It's a beautiful day today. I've got the door open, the sun's shining, it's nice and peaceful. So we'll see where everybody's from.
Yeah, let us know in the chat. The other thing is, I can see Taquito's question there. There's a lot of special sauce is all I'm going to say to that one. So S3 is a pretty awesome service that AWS has created for object storage. It's a very complex, very awesome service that we could spend days talking about. But good question. But
my comment on that would be, I would say, at a high level, Amazon is a long-term thinker. So the mechanisms that they've come up in place to be able to provide such a durable, such an unlimited service for customers such as S3 means that they're not taking a short-term view about this. So they've invested heavily in specific technologies that make sure that they have the redundancy, they have the scale, they have the performance that they need, and as well to do that in a mechanism that is cost optimized for the customer to consume, but cost optimized for us to be able to, if you think about the original time when S3 was introduced, you introduce a service that provides unlimited scalability and 11 nines of durability, and maybe the 11 nines wasn't back then. I'm not sure when they turned that on, but that's not something that you can just scale as the customer come on. So you need to be a little bit thinking about the future and how that goes. So there is some secret sauce that's going on there as well.
And I was going to say, it's good to see Aaron's on down the road from Matt. That's correct. Sometime I'll have him come over and we might have him come back for Amazon location or something like that. And we'll stream it from the cabin together, or maybe some Microsoft.net stuff as well, if that's of interest to the audience. It's cool seeing that we've got a couple of people from India and the UK here, and Seattle too. So we've got Lithuania, looking through the list. So that's really cool. What we might do though, because I do want to spend most of the time kind of looking at what you've created, Paul.
Yep.
is let's quickly jump through some of the announcements. And this one I thought would be more for you. You're more the quantum computing scientist than me.
Well, I did see this release of Amazon Bracket. Now there was a video of Jeff Barr when he introduced Amazon Bracket. So Amazon Bracket is our quantum computing service. And if I find that video, maybe when Matt talks about his piece, I'll quickly look it up. I guess you watch that, and most people are going to be like, what was going on here? Like, this is like really difficult to follow. But I've seen the way some of our customers are looking to use Amazon Bracket and the specific niches where our internal SMEs are leaning on Amazon Bracket to solve complicated problems that I guess that, ordinary developer folk have no idea on how to go ahead and look at something like this. I have never come across somebody within my working life that is built on quantum computing so far, other than people just roughly talking about it, and that might be something interesting. I will make an assumption that nobody in the audience today has touched Amazon Bracket and has built something, and if they have, I'd love to hear what that is. And I mean, we've been talking about
come on the show, tell us, do an episode on it.
If someone's got something that's they've built on Amazon Bracket or could talk about it, come on the show and demo something, we would make sure that we would have some devs in the shed swag for those people.
Yep, exactly. Yeah. So the next one that was quite interesting was code build here. I'm just making sure everything's zoomed in so most people can see it. I might go one more step. There we go. So code build supports ARM. This is really good. I guess in a broader context, you can now use ARM with Graviton across most of your traditional applications. So you can leverage Graviton and EC2, your containers workloads that might be using ECS and EKS. It's a fantastic service. It saves a lot of money. ARM is amazingly powerful. And, I've got an Intel Mac and an ARM Mac, and the ARM Mac really surprises me in the way that it performs sometimes. And, I love my Intel, I love my ARM, I love my AMD. I'm not really biased in chip manufacturing, but so far some of the latest ARM experiences have really impressed me. But this is really good from a cost savings perspective, right? You're not going to be running your workload on it, having to deal with some of the issues, the things that are compiled for x86 and stuff. You can simply, if you've got code build, you can select ARM instance types for the build process. It's very similar to what we've done with the database side of things as well. You can use ARM for databases too. And I think these are really quick win, large cost savings, large performance gain type things that you can do when you're using AWS in the cloud. So moving anything that you can to ARM is going to be of great benefit. You might have to rethink that based on how you've built your app or some of the binaries that you've got that are x86 based. So you might have to do some testing for EC2, but turning on ARM for RDS, turning on ARM for code build is just an easy win, right? I don't know if you have anything else to add to that, Paul.
I'll just say the same thing. I also think that ARM is just cool. It's just a cool thing. I like to build on ARM when I can for the the reasons of performance and cost, but also I think it's pretty cool to do. But I've found that most of my applications I've been able to basically just recompile across, set up all the packages that you need to go ahead and do, and they've worked really well. Some older applications, you might find there's some challenges there if they've got some sort of binary that you can't update that's embedded in the application. If you're looking to save some costs and you are building currently for ARM, whether that's Docker containers that you're publishing or packaging something up and deploying it to Lambda or something like that, this is going to be a cost savings, an immediate and good cost saving. If your application is not using many threads to go ahead and build it, if it's not something that's forking off, then going to 2 vCPU is probably going to be not a noticeable difference in the performance of the build.
Yeah, I'm also a real stickler for everything the same, right? I build on my Mac M1, Dockerize it. I can then deploy that to ARM on the clouds, but I can also test locally on my Raspberry Pis, right? So now I've got more of an excuse to bring my Pis out because, everything that I'm building end to end is for ARM too. So I guess that's why I like ARM, right? It started with the Raspberry Pi and then it's kind of gone from there. Anyways, let's move to the next one. So EKS connector is in public preview. Do you want to speak a little bit about this, Paul? There's one that's an EKS update that I'm really, really excited about, and that's the next one. But let's briefly touch on this.
So I guess when we think about this, and it comes off the back of, if people have been following our segment for a little while now, that we had Jason, one of our container experts, come on and talk about ECS Anywhere. And ECS Anywhere allows us to have the control plane within AWS, but the workload or the compute piece itself running on premise. With this specific release, and also it was the release for EKS Anywhere came out recently as well. EKS Anywhere allows you to run EKS like on premise on a separate environment, but requires some additional configuration around VMware. Whereas the EKS connector allows you to connect conformant Kubernetes clusters into AWS and visualize them in the EKS console. So in this way, you can say, look, I have a cluster that's running like on premise, so not necessarily distributed specific workloads, but a cluster that's running on premise, and I want to be able to see what's happening from an instrumentational point of view within AWS. So as long as that there's some conformance around that Kubernetes cluster, and that all is all mapped out within the documentation, you can connect that to within EKS inside the console there, and you can have a look and see what it looks like to see your cluster that is operating on premise or on some remote location, whether that be an alternate cloud. And I guess in this instance could also be a cluster that was running, that was self-baked, a self-baked cluster that you were using like COPS or something for within your account. So you'd be able to connect that and see that as well. And that might be to provide you some overview in what you're working through to migrate that cluster into EKS and take advantage of, AWS taking care of the control plane and looking at that for you, and all the additional features that come up with using like EKS rather than just Kubernetes itself, because there is a lot of advantage to leaning on top of EKS, such as the way it connects to storage, the way IAM and policies are put through, the way your EKS clusters and nodes tie into your compute savings plans, for example. So people are going through that transition where they want to be able to slowly move those workloads from on-premise into the cloud, or secondly, they have a cluster that's running on premises and want that same visibility of the rest of the workloads that are running in the cloud. So that was an interesting one to come out last week as well.
Yeah, and I mean, we've played with ECS Anywhere. Yeah, go ahead, Paul.
Yeah, I wonder if anybody in the audience is working daily with Kubernetes and whether that's a topic that we should go into again. I know that I've set up Kubernetes clusters at home. I have an EKS cluster running with some things on it. But yeah, it'd be interesting to see if people are playing around with that and poking at it, and something that people are willing to learn. So let us know if you are, if Kubernetes is something that we should go and revisit in one of the future shows.
Yeah, we've done a bit on ECS Anywhere as well, right? But I'm definitely sure that like there's people that would like to see EKS Anywhere up and in operation as well. On that topic, like feed us some ideas as well, right? Like we've got a couple of things that we're planning, right? Like we'd love to do some green grass stuff soon. We know that like coming up to Christmas, it's usually like the holiday season. So a lot of people are thinking about like, how do I monitor my apps better? How do I make sure that my apps can scale out? So like we're thinking of doing some sessions on like chaos engineering, fault injection simulator, or like CloudWatch alarms, and like some of that basic stuff. So that might be of help as well. So like call out if any of those are appealing to you as well. But what I'll do is I'll move on to the next one. We'll go to one of my favorite things in AWS, CDK. So CDK has improved support for Kinesis, Firehose, CloudFront, Cognito, and a few other things. So this is really good. I think Amplify last week as well, like there was an update for like what CDK can do there. So this is really good to see, like, supporting additional services. I know that like, the service gets released, it rolls out into CloudWatch, sorry, not CloudWatch. I can't speak today, CloudFormation, and then like it comes into CDK as well. So it's good to have like closer parity between like things coming into CDK. Any comments on this one in particular, Paul?
No, other than it's just nice to see the continual updates within CDK. And again, we still hear the pain of people, the breakage that will happen. I'll assume that same will happen with the dependencies and the package integration with CDK1. So great to see new releases. Probably like many of you that are building on CDK, probably can't wait to see CDK v2 become, generally available, and we can move towards that.
Yeah, like I feel like this is really getting ready for like CDK v2, right? Because I know some of the experimental libraries suddenly popped out of the main CDK documentation, and they have their own little repositories, like as they're marked on experimental. But I know that CDK v2 took the stance of like they are very separate. You added them into your project very separately, and so I think a lot of the service teams are like jumping to get on board with CDK v2. And making sure that the libraries are fully up to scratch to what customers expect, which is really cool. The last big one, this was a little bit of a surprise for me. Elasticsearch is now called OpenSearch. And so we've added support for OpenSearch 1.0. This one I've been diving into over the last week. So I've got a couple of customers that use it quite often. And the idea is that, like if you've got an existing Elasticsearch cluster, it's going to work completely fine. The migration to OpenSearch is going to be really, really smooth for end customers. At the moment, you can still call like the Elasticsearch APIs, and they're going to allow you to interact with like what's been upgraded to an OpenSearch essentially as well. So there's good compatibility of stepping in. If you built things in CloudFormation, CDK, they're still going to deploy similarly as well. But this is kind of like a really nice stake in the ground to say like Elasticsearch is a really good service. We now want to give it a brand new name, and we're going to invest a lot of time to make it even better for our customers, because I don't know a customer that doesn't use Elasticsearch, to be honest. It's one of those critical pieces that's there next to EC2 and like RDS and S3, etc. I'll let you comment on it a little bit as well, Paul.
I just think that it's the fork of Elasticsearch is great for the community. Like, so now it's supported by Elasticsearch itself, but also one of the big vendors now that's behind it. So innovation will be able to. I mean, when you have competition, that breeds innovation. And so having this support to Elasticsearch is just good for any consumer of AWS's Elasticsearch product. Forking it into open source, it is good for any consumer. And I guess we would probably see continued benefit of over time of the close integration between OpenSearch and the rest of AWS's platform base.
Yeah, exactly, and it's cool to see like it be open source for the community to add in as well. So that's something that you don't have to use with an AWS LAN. Like you can deploy it yourself elsewhere if you needed to for the local testing or whatever. But like a lot of the stuff's going to be quite transparent to like the community in terms of like where it's going in the future, what's the roadmap look like, etc. So anyways, yeah, that's really cool. Last but not least, Paul wanted me to put the shameless plug in. So thanks, Paul. But I did PyCon Australia last week. And so the video came out like yesterday. I'll just put it in the chat for everyone as well. It goes for about half an hour. But this was a story more than a technical presentation, I'd say. It's about a story about a real app that was built for community groups and sending like event items across to different people. And so like I built this thing, but at the very start, like I always generally want to overcomplicate things. And so I'm trying to find that pause video moment. Yeah, I can't find it, but I had like 50 different things I wanted to do with it. And it was like a weekend project. And I kind of settled myself down. I'm like, no, I just need to produce what's needed for this use case. And then it kind of evolved through there. So the architecture kind of like grew massively. But if I'd established like set stone architecture and an idea of how I wanted everything to be built, it wouldn't be what it is today. So that was kind of the point of the talk. And it also talked through some of the technical complexities along the way that kind of led to decisioning of like why I did things in a different way to what I'd originally planned as well. So give that a watch if you want. appreciate the support.
And
there.
Matt, did you have any feedback about microservices? Because it's always such a contentious topic. So whenever you talk about microservices, it's a very much a religious debate. And Matt and I, and we discuss this topic often, that you have to start small. You have to start with the application and what the users are looking to. And building a monolith is not a bad thing, but there's a time and point where you have to think about scale and what it looks like in the future. So I think that tied into a lot of the story to say, be careful about what you're building and pay attention to what your customers are asking for rather than what you think is going to be good. Like if you build it, they won't necessarily come.
Yeah, and I to be honest, like spoiler alert, but I went down the Chalice route. Like we've done Chalice before, AWS serverless, Lambda, API gateway type stuff. And the reason why I ended up doing that was because I realized that, like the interactions with the backend were fairly simplistic. It's like someone puts in their address, they put in a coupon code, it goes into the ordering system, and then there's only a couple of other things that happen before it gets passed to the vendor and managed by the vendor that's going to fulfill the order. So I went down that route, but I did get presented with, like, I was originally running on Beanstalk, right? And I kind of had that turn. It's like, do I containerize it? It's still going to be quite expensive. Like it's been used for a lot of different events now. And so I kind of had a look at that microservices approach, and it would have been easy to make it a microservice. But yeah, I ended up choosing serverless. So yeah, I talked about it a little bit. I'm in that camp where it's like, do whatever's right for the workload, right? So if you've got a monolith, it's going well. You want to focus on building other new things within your environment. That's perfectly fine. If you've got a monolith and something's breaking in particular and it can be easily separated out, like you could use microservices for that stuff. But one thing that I've learned is, like, working in multiple SaaS companies and technology companies in time that have like been developing architecture, is don't expect to fully replace everything all at once and we're going all in with microservices, because it ends up taking the company 5 years to go on that journey from my own personal experience to get there. And you have this awkward moment where customers are like, your product doesn't work. So, I've got some learnings there. But yeah, anyways, let's move on, because I am keen to see the Raspberry Pi stuff.
Yeah, so I think to gently introduce like what have we built and what we talk about today, I think to kick it off, and this might be interesting for the audience, like we're not exactly sure what will happen when I go ahead and paste this, but we would like the audience to be able to see whether this like specific stream works. Now, if we have a quick look here, we can see that I've like connected up my Raspberry Pi. So I'll do a little bit of a show that like that is connected to my Raspberry Pi that's sitting over there.
No green screen. You're actually in your shed.
I've got some duct tape holding up the other camera, and I'll just quickly show how what that looks like there.
I'm just making a bigger view. There we go.
You can kind of see that like I have a tablet sitting there, and then behind it I've got like a relay, and I'll go into that in just a second, and an electric motor that my son built and sort of put together. And so yeah, duct tape is extremely useful. So what I did was a little while ago, I had built and set up and configured the network at my house to be connected directly into my VPC within AWS. And I'd had that for a while, and that's really handy, because when I want to go ahead and connect to some of my resources within the cloud, whether that be an EC2 instance or a database, because I want to interrogate the data or run ad hoc SQL queries or something, effectively at home, I am sitting on the AWS network. And I've done that using StrongSwan and a site-to-site VPN, and I'll go into a little bit more of the architecture in just a little bit. But it's very handy. It means that I don't need to like dial into a VPN. It means that I have a site-to-site VPN that's always on, that all my internet traffic from home routes directly out through my router through the internet. But for specific routes, for those site arrangers that exist within AWS, there's an additional route that exists on my machine that says route that through that IPv6 tunnel and my connection with StrongSwan that goes directly into AWS. And so what that gives me is the ability to connect directly into AWS, But the reverse side of that, it allows my AWS account to reach in directly to my home network. And so
I was going to say that's a lot more secure than what I used to do, Paul. I always use Dyn DNS, right? And I'd have like a static IP, Dyn DNS, and then I'd just basically like from the router, like point it to my particular endpoint and then make that accessible.
Yeah,
you've gone the complicated route. That's good. Yep.
I went the complicated route to set that up. So I've definitely done that before. I've hosted emails servers at home, like back in the day, web servers. Like, I mean, it's mandatory for somebody that's likes tinkering. So for any tinkerer, like that's something that you should know how to set up. But that means my public IP address is exposed all the time. So it puts something in the middle that says, look, if I post this somewhere, then somebody might be like, do something to my home IP address. Like I lose some anonymity around what I'm doing. And so that's why I came up with like this other way to go ahead and route it the other way. Now, what I'll do is I will show the endpoint so that people can go ahead and look at it. So what you saw in the I pasted that link there, so it's /PIE just for fun instead of PI. But that is connecting to a application load balancer that exists in AWS. The application load balancer is pointing to a target group, and the target group is then routing all the way directly to on-premise. So what I'll do is I'll share my screen and I'll sort of draw up the architecture while people are just seeing whether that looks. Now, if my internet goes bad, it means that lots of people are like looking at that. I don't really know what the impact is, but we thought we would give it a go. Worst case, I'm just going to have to pull the plug and turn that off. But I'll share my screen and sort of draw up a bit of the architecture of what I'd implemented here. So I'll have it in Lucid chart. So I'll say on the right here in this area, that's my home environment. On the left here, that's my AWS environment. And what I have is like inside that VPC, I have a number of specific side ranges. So that's that VPC that exists there. But I have we'll see whether I can get the VPN gateway. So I have a customer gateway that exists within this VPC, and on my home network, I have a second Raspberry Pi. And so I'll just use this box as a second Raspberry Pi. And this Raspberry Pi is running StrongSwan. And so StrongSwan here is performing like what is required to open that tunnel between my on-premise environment and AWS. And so that exists both ways. So that specific line, where's the other?
And I think that answers Halep line as well. I've just put on the screen. Like this way you can use your VPC as a public tunnel for your local services, right? Somewhat.
Yes.
Yeah,
yes,
right.
exactly
like
right.
at the end of the day, like that's what you've got with like
that's exactly right. Yeah.
The LB link. Yep.
Yep. So this is a Pi 4 I've got. It'll run even on a Pi 0. So I had it running on a Pi 0, but because the Pi 0 is wireless, it was you would notice the throughput was a little bit less. The Pi 4 was a lot bigger, a lot more throughput, and that's running StrongSwan. And there's a couple of articles around going ahead and setting that up. Now I know somebody asked the question like, what's the cost per month?
Yeah.
And I'll be honest, like that's a good question because I've never looked. Working AWS gives me the freedom to have accounts that I don't have to pay for. But I'll go ahead and I'll look that
everyone
up.
will end up working for AWS if they realize they get like unlimited access.
Yeah,
to AWS
I'll look
services.
that up and I'll provide that. If we looked at the docs, you'd be able to calculate that. I don't think it's exorbitant because I do see the bill, but I have never looked at it, and I know that bill is not exorbitantly expensive.
We do be frugal with what we use, right? Like so, like when we finish a project, we spin it down. We get embarrassed if we've eaten up more than a couple of $100 as well, because it's very transparent how much we're using. So I'd suspect the solution's like really really cheap at the end of the day for you to run, Paul, because it doesn't come up in any conversation, right?
It doesn't come up.
Yeah.
So while I'm technically saying this is a VPC, I mean that's just my home network, right? That's and like most people at home, it's 192.168.1.0/24, right?
You're on the same IP.
And So what this means is that my home computer here can go ahead and if we put like a modem, use a modem as the icon here. So I effectively have my modem here. When I go to the internet, my machine goes on my local network to my modem out onto the internet. So if we've got a cloud out here, here's how my modem goes out into the internet, right?
Yep.
But when I want to make that connection to, like, let's just say this RDS instance, normally what you'll do is either open a VPN connection to do it, or connect to like some sort of bastion that exists within a public CIDR range or a public area, a subnet of your VPC. So you might have an EC2 instance that is sitting within this public area here, and then you would go out to the internet. The internet would go back into here, and then from here you'd go ahead and be able to connect, to that database and run some queries against it or whatever that might be. This solution allows me to go directly to my site-to-site VPN, and that handles all that traffic and movement. I'll redraw that arrow. That now enables me to connect directly to that database. Now, interestingly, what it's also done is I have done this, and I've done this more successfully than I guess you would think. That I've run applications like with Lambda. Oh, that's funny how the whole box.
It's consumed the whole box. Yeah, that's funny. Yep.
It took the whole box.
Again, drag it out and then drag it like in it. Yeah, there we go.
So I've had Lambda functions running in my account that, for reasons that you would do only to try, have connected to at home on my home network to a database running at home. So I've run SQL Server Express at home or Postgres at home, like I do that at home. And like I've run those databases like on my home network on a different machine somewhere, and have enabled Lambda to connect back to on-premise to those databases. So it allows you to see how these things perform in real-world situations, because these types of things, while maybe not necessarily recommended as a long-term way to go, there's a lot of customers that are doing this at the moment. So they are working with applications that, the application might be running, on-premise, completely on-premise with a view to move to cloud or a refactor into cloud at some point in time. But you might have specific tasks, jobs, API endpoints that might exist that need to reach back onto on-premise. And so these are the mechanisms that is one of the mechanisms that you can go ahead and do. Now, if you don't have access to Direct Connect, now obviously I don't have that at home. And there are many like small to medium-sized businesses that maybe can't afford to do that, or they don't have the requirement to go ahead and do that. This is just one of the options that you can do. Now, obviously running Strong Swan on a Raspberry Pi is probably not something you're going to want to do for a production workload, but Strong Swan can be installed on any Linux system. But you might also require a specific hardware device to be able to, a Cisco device that sits on premise that handles all of that for you. So there are many different options. But what I have is effectively like close to a performance grade implementation security wise, by doing that with like, very little financial outlay and having like quite good throughput all the way through. So my uploads at home is about 40 megabits, and I can move data in and out of the AWS accounts, around about 10 megabits a second. No, even higher than that if I'm doing something like local. But if you were looking at that specific Pi address that I put in there, like /Pi, and I'll make the assumption that some people are looking at that at the moment, that you can see that like it's reasonably responsive. So if you open that in a second tab and you have a look and you see that I'm like waving my hand in front of the camera, you'll be able to see that like pretty quickly you can see that that's going through. Now, if I quickly draw what's happening there, it will give an outlay of like what I'm going to talk about a little bit more today. So I have Strong Swan running here that gives my home network the ability to be able to connect into AWS. I have a second Raspberry Pi that's running in my environment at home. And that Raspberry Pi is running Nginx and Python. So Nginx is running just purely as a reverse proxy. And I'll explain that in just a second as well. So that's reaching directly to that on-premise to there. On the other side, I have a target group. Failed me.
And I can see the Pi URL struggling, so it doesn't look like it's your bandwidth at home, Paul, but something down the pipe slowing down with everyone calling it. So this is good to see. Yeah, it's a little bit
weren't
laggy.
Sure. We thought it'd be interesting to break my internet rather than just talk about it. We would demonstrate it.
It looks like you've got something further down the pipe. It's not your internet this time, so we'll have to have a look at it. It'll be cool.
Yeah, we'll see what's happening. We'll have a look at it in just a second. So
for Andre wants you to wave like in front of it, just very quickly.
I'll put my hand in front of it.
So yeah,
I'm doing that now, Andre.
Yeah, so I can see it keeps like
it's a bit jerky.
Beach balling, but I can't even see your hand. Yep.
Yeah, well, since I'm sharing my screen, what I'll do is I'll quickly show what that looks like.
Oh, there we go. There's your hands now.
So this is I'm using IP webcam to do this. Now, IP webcam is installed on that older Android device that is running at home. Actually, this is a wrong IP address. I also have a rock tumbler, so I have 2 instances of this running at home. And so this is the second instance of that application. Now, it must be struggling, and I suspect what it's struggling is the device itself, because usually this loads really quickly. So it's an older Android device that is running, and that once you go ahead and start that, it basically sets up a little web server on your Android device on your home network. From your home or your local network, you can browse to that IP address /port 8080, and I think the port's configurable as well. And then you have this interface that lets you see what's going on. You can change the zoom here, so I can go ahead and I can adjust the zoom. It's doing a digital zoom on that. And I can change the stream quality. So maybe that's what it is. Like maybe if I drop that stream quality down, it might be more responsive, but a bit more blocky. So we'll see now whether that changes anything a little bit. But what you can see is, like, I've got a couple of lights here as well. Now, to make it fun, I made sure that what I was doing with that tunnel proxies directly to a couple of specific endpoints that you can turn those lights on and off. So if people want to use that URL, and I'll paste that in just a second, or maybe can you paste it in, Matt? Because when I go to
I'll paste it in. I was going to say Max Payne just called out on the chat that you could put a clock in front of the camera just so you can kind of see the time if there's a bit of a lag. So
I'll show that in a sec. Yeah, that would probably be something good to be able to see it. So the lag probably shouldn't be too major. We'll see how it goes. And maybe at some point in time, like a better mechanism to do that would be to be using one of the broadcasting solutions that have come out, where it takes one pipe from my area and then distributes to everybody. But I guess what's happening now is the way that it's set up is everybody is sucking that equal amount of bandwidth from my home network. So they're putting like quite a bit of pressure on the device. But I can tell someone in the audience is hitting that URL there. So they're able to turn that green light on and off. And all that's doing is like turning a trigger on and off using GPIO pins on the Raspberry Pi. There's also red and orange exists there as well. So people can go ahead and turn those lights on and off and see, have some fun, turn that thing on and off. But when I go back to the architecture, like this is effectively what I'm doing. So as a user, you are connecting to a public application load balancer, which is sitting within there's a bunch of people doing it now. Like I can tell they definitely have.
I didn't give everyone the red URL. I was like, have a guess as to what the red URL is, and I think it's pretty obvious.
Yep. It's what we're seeing here is like I'm protecting my home network from somebody understanding or knowing what my public IP address. They don't necessarily know what that is. There's a buffer in between. But you're coming in on this application load balancer, and I'll quickly just go into the console and show that. So at the moment, you can see like I have this on-premise target group that exists, and that's sitting behind that load balancer. Now, this Raspberry Pi at the moment is plugged in via Ethernet cable. So that is the private IP address of that, and you can see it's healthy. I don't have Wi-Fi, the SSID for this Wi-Fi enabled in the shed, so that's going to go unhealthy. If I was to go back inside, those IP addresses, even though they're on the same machine, they would both come up as being healthy. And so then I have a load balancer, and I'll quickly show that. I think my computer doesn't like streaming multiple cameras all at the same time. It's kind of, and maybe that's just my internet. Matt, are you still there?
Yep. Yeah. Your audio is coming through. The video is fine on my end. So, yeah.
I suspect my internet is a little saturated at the moment. So, yeah, once that loads up, we'll see that I have this on-prem load balancer here. And that has the listener is going to that on-prem target group, which is linking directly to my on-premise environment. So if you were to go back to that target group, and this is where it becomes, you can't just put a target group to a public IP address, and you can't put it to a private IP address that isn't routable through the gateways. So this is all depends on your routing tables and the routes that exist with that VPN. So I have the ability to communicate on and off, and I have in place routing rules with the VPN that enable traffic within my VPC to know where to go when somebody requests an IP address in the range of 192.168.1. It knows that when it's trying to route that traffic, it should route that through the customer gateway back to on-premise. So if we go back to this and we look at like what it is that I've done and set up at home, I've got like an extra app that's running on that same Raspberry Pi, but that's a little Flask app. Again, that's using Python. Why did I use Flask in this instance? Well, one, because it is Python that we're going to go ahead and integrate with the GPIO pins, and I'll show the program in just a second that I did that. So Flask is what is being using the /red/green, and there's another one /motor. So if you do /motor, you can go ahead and turn on the electric motor that you can see in the background. And what I might do, because it's a bit blurry, is I've got a marker here. I'll put a mark. Oh, someone's turned it on. I'll put a mark on there so you can see that turn around. So if whoever that was wants to go ahead and turn that motor on, should be able to see that turn. Yeah. So somebody is turning it on and off, and you can see that is going ahead and stopping and starting that little motor turn. Now, /motor, /red, /green, and /orange are all reverse proxied to that Nginx server. So all the web traffic is hitting Nginx, and based on the path, it's doing a reverse proxy either to the Flask application, or if it's /pi, it's going across to that Android device. So this is that Android device here that exists on my home network. And so I am performing a reverse proxy that says from that specific machine, go across to there. But the Flask app is also doing a reverse proxy. However, that happens to be local on the same machine. I'll just wonder, Matt, like, is there any questions coming through to explain that a little bit more? Is it clear? Because if not, if it's okay, then I'll go ahead and I'll show both the Nginx config and some of the code around the application that I built here.
No questions, but I think Max Payne was liking the marker and the first one, the call red, so I might call him out as well, and might actually say I've played all 3 Max Payne games. They're pretty good, so I like the handle. Let's keep going.
Yep, cool. So what I'll do is I will unshare. Can you remove my screen? Huh?
Yeah, I will pop you out now. Yep.
Okay, so what I'll do is I'll share a terminal.
Someone's asked what type of motor that is, Paul. Is it a stepper? How is it interfacing with the Pi?
I think that's just a little electric motor out of like a toy or something. So my dad's an electrical fitter, and my younger son likes to pull things apart and break things. So my dad got that little electric motor from something. I think it was a very old video camera, actually. So it's not a stepper motor or anything. But to answer Max's question, what I'll do is, first off, I'll show the Flask code. Then I'll go back and show how I wired that in. So I'll share the code.
Yeah, let me know when to share. The other questions are around like, is it a 5-volt pin that we're using on the Pi for it, etc.
Yeah, I'll show that in just a second. So what I'll do is I'll quickly just show, this is my Raspberry Pi here. So I'll quickly show, if we go to, so here's the simple way that I set up these reverse proxies to use Nginx. So I still love Nginx. Having the ability to have all traffic come into one place and then to be able to fan it off to specific different devices is really, really handy. Now, I could have done this through the load balancer and proxied that all out to specific devices, but I wanted to do it like really quickly and not overcomplicate it. But so basically all incoming HTTP traffic to that endpoint or that public endpoint goes to this Nginx server, and slash goes directly as a proxy to that Flask application. So the Flask application is running on port 5000 on the same machine. So it says anything that comes in for slash, redirect that to my Flask application running on port 5000. We can see here the location /pi is saying pi reverse proxy that to that IP address of the Android device on port 8080. And /video is that little video image segment that everybody was seeing. So rather than having all of the controls, and I could have exposed all of the controls so that people could, change the zoom and all that if they wanted to, but that would probably end up in mayhem. So all I'm doing is exposing that little live video piece. So a very, very basic set of configurations that is doing all of that proxy work. And secondly, for people that may not be aware, using the location / here, I want everything after the / to also be proxied as well. So it's very important to, when you're setting up your proxy path, to not just put the / like that. You must have that trailing / at the very end. So it says if we do /red /green, that's going to proxy across to that that Python application. So if you were to hit an endpoint that didn't exist, it will look to Flask and say, hey, something doesn't exist there. It's not working. If my Python application was down, that's going to give a 500 because the upstream to port 5000 isn't going to be there. So what I will do is also now show, and I've used the same style of code to do the repeated motions through all of it, but I'll explain what I've done, and that will go down and answer the question around how have I set that up with the 5-volt pin. So basically what I've done with this application is make sure that I'm pip install GPIO, so the GPIO libraries for enabling interfacing and interactions with the Raspberry Pi itself. And that enables me to turn those pins on and off. Now, when we looked at in the bottom right in the camera, you can see that, I'll try zooming that in a little bit more and let that stabilize. You can see that that is the output pins that are coming out of the Raspberry Pi, and I have the ability to control those by turning them on and off. Now, those pins are just pins with a number. So if you were to look close enough, you may or may not see it. The wire that is going from pin 23 on the output of the Raspberry Pi is going directly to the positive side of the orange light. So when we go ahead and set up a route for orange, so that's route orange /orange for the Flask app, a function name, hello world there for whatever reason. For this instance, I used a global to be able to have a flag to whether I'm turning that on and off. But basically, I say set up the mode for that pin, set up the mode gpio.bcm, which enables us to be able to work with those specific pins and output pins that are on the board. And then I say for pin 23, I want that to be a GPIO out pin. So that is, we are going to be able to then send a high or low signal to that rather than read from that. So that's what that light step is doing. And then there's just some basic Boolean logic that says if the light is on and I have a request, turn the light off. So just flip it the other way. So set that pin to low if the light is on. If the light is off, set that pin to high and set that that variable. I cleaned that piece of code up a little bit more with the green, and I've repeated that through the rest of them. But basically says do the exact same thing, but get me the status of the pin rather than carrying a global variable. So get the status of the pin. If the pin is high, so we know the light is on, go ahead and turn the light to be off. If the otherwise, go ahead and turn the light on, and then return the status of that pin, which is why when you see For green and red, you get the status of 1 or 0. Like, so that's just the Boolean that's going around that. To answer the question about the motor, that's literally exactly the same. So what I'm doing there is setting one of the pins. So pin 16 is the pin that's driving the motor. But as we spoke about earlier on the show, when you're dealing with the Raspberry Pi, the Raspberry Pi is powered by, basically by USB. I could plug that Raspberry Pi into my laptop and that would go ahead and work. But there really isn't enough current from the Raspberry Pi to be able to drive a motor and to start that motor up. There's enough current and power to drive those LEDs. No problems there at all. But to drive the motor, there isn't. And we tried. I tried that just to see what would happen, even though I risked like damaging my Raspberry Pi by drawing too much current. It doesn't work. So what happens there is, like, this is a little bit additional to what is going on, is if we look at, so here's this green wire pin 16. So if we look at that at pin 16, that's the motor wire. And I'll sort of try and move this camera along. So pin 16 is going along into this ribbon. I'll just see if I can. Yep. So that's
just trying to make it more full screen. Yeah.
Yep. And that goes into a relay. So I have a relay sitting here. And I'll see if that can focus in just a second. So here we have a relay that sits between the motor and the Raspberry Pi. So from the Raspberry Pi, there are 2 pins. So there's the 5-volt pin, which is being powered directly off the Raspberry Pi 5-volt. So that's very low current and very low power. The ground, which again is just being powered off the Raspberry Pi. Now the relay can be powered independently, but I'm choosing to power the relay off the Raspberry Pi, and a signal wire. So the signal wire is that pin 16 that says I'm going to give a high or low signal to this relay. Now people can't hear it, but I can hear the clicking. So every time the motor goes on and off, what is happening is the signal is coming on the green signal wire, which says high. And that says, go ahead and engage like a larger switch that enables voltage to go. Try and adjust the camera. Not doing a good job of doing this. Here we go. So if we see the other side of the switch here, yeah, I think it's starting to play up now. It's been turned on enough that it's gone a bit funny. Oh no, someone's spamming it. Someone's definitely spamming the relay. I can see that that's happening. But what is happening here? This relay or that signal wire is engaging like a heavy duty switch that enables a lot more current to go through. Now on the other end, you see these 2 other pins like here, and here I've got an external power supply, which is actually putting, I think it's like 6 volts at the moment. So that is powering 6 volts with like 3 amps or something through that powers that little motor. So the Raspberry Pi sends out a high signal. The high signal tells the relay to engage the higher powered switch. That high power switch then enables you to put across 6 volts to that motor, and then you can safely turn on and off that motor without damaging the Raspberry Pi itself. So yeah, like I kind of wish that some people could hear it, because someone is definitely holding F5 on it.
We can hear it actually secretly.
Okay, you guys can hear it. So I can see it going on and off. So someone's doing that a lot. And because inside that relay, so that's a relay is an electrical switch that says, if you provide me with like power to enable something, and then you provide the signal which turns it on, it effectively moves like a lever inside that says engage this switch that enables high current to be able to switch through. So that clicking is that switch internally being switched electronically backwards and forwards. So this was like a bit of fun to go ahead and set this up, and probably more fun going back and thinking about some of the architecture that I've gone and built, and like figuring out how to set up the routing rules, working out how to configure and set up Strong Swan, and working through that process of being able to expose things that are running at home back out onto the internet and still protect my home IP address, and making sure that people can't like denial of service attack my home IP address, that's going to go through AWS, which then means if I wanted to, I can go ahead and put CloudFront in front of it, or Shield, and enable like the specifics around AWS security to leverage what is happening and running at home on premise. And why we specifically thought about the lights was, well, Christmas is coming in some point of time, and we were thinking that it would be fun to extend on this, because this is like nice. It's a nice little tinkering sort of experiment, but we wanted to build an application where we could have a web page, and that web page enables you to call some APIs, and then people can, set something up that potentially like streams a message to people or flashes the lights for some people at a certain period of time or something. But be able to build some application that connects directly onto your on-premise locations, and do that in a mechanism that doesn't necessarily cost you a whole lot of money. This is like completely affordable to be able to do at home. A Pi Zero, if you were to go ahead and set this up, that could do the exact same experiment, would cost, they're like $35 or something. An Arduino kit that comes with all these GPIO extender boards and the wires and some LEDs, another like $15. And you can start tinkering with some of this at home. And what it does mean is, like, I think like somebody earlier when I was chatting to them about it, was that if you wanted to, you could go ahead and plug that into, I don't know, something else at home that you wanted to turn on and off that wasn't necessarily enabled directly by like a smart switch or something like that. So yeah, I think Haloop, and probably what I'll do is go ahead and put something in to say, don't like allow an exponential back off. So if it's changed in the last second, don't allow that to happen. But I mean, like, what's the worst that can happen? They'll break the relay or something. It seems to be going okay. But yeah, you could go ahead and do that. So Max said you could do the exact same thing with 240 volts. So that specific relay I bought was, I think, $6. And that can do, I think it's like DC, like up to 30 volts, 10 amps, and 10 amps, 240 volts as well. So you could use it 240 volts. Obviously, for anybody that's unfamiliar, don't touch anything other than more than 10 volts, because you don't want to get an electric shock or something like that. Yeah, so got to be really careful with anything above. I would just say anything above 12 volts. Be careful at that point in time. Even with 12 volts, if you're using a battery and you accidentally short it out, you can get a spark and you can create some heat there. So yeah, that was the overview of what I did and what I built out. Now, I thought it was like quite fun to go ahead and build that. And did anybody have any questions about, like, specifically about the code or what you might want to do or how that worked within the AWS environment? It's the amps which kills you. Yeah, that's right. Yes, because what we were thinking about next was, like, this is, I would say, the solution here is like less than cloud native. I would say, like, so not using things like Greengrass. And if we were to use Greengrass, that would be a little more, we'd be able to put some rigor and CI/CD behind what we were doing there. Whereas at the moment now, like, yes, I could go ahead and put CI/CD, and I could use code build, code commit, code pipeline to be able to reach onto my own premise and make those changes. So that's perfectly achievable as well. But using, like, leveraging Greengrass to be able to completely disconnect those would be useful. So we were thinking about going ahead and enhancing this application and installing Greengrass. I didn't have the time to go ahead and do that today, but like, that's probably what the part of the next journey is going to be for us. But knowing now how easy it is to configure those libraries within a Python application, we can use Greengrass to package up our Python applications that are using the GPIO libraries to be able to deploy Lambda functions to my device that is running on premise. And have all of that abstracted away with AWS. That enables me to turn things on and off, or do things at home that you may otherwise not be able to do if you are interested in electronics or building something offline. But secondly, if you are a tinkerer, and I guess I encourage everybody to be a tinkerer, when you're building things at home, exposing it to the internet, it's never happened to me. I've never had somebody, like, I've never been hacked. I've never had my SSH password compromised or something like that. But this mechanism puts an additional buffer in between. So I'm making sure that whatever is on my home network, and whether that be, like someone earlier said, they wanted to set up a NAS, that my NAS is no longer exposed, so that if I've got photos or something on my home network, getting all the way through. I haven't been hacked as far as I know. As Eks says, I haven't been hacked as far as I know. And so it's an additional layer on top of that, because of this, by hooking into AWS and having some sort of proxy in the middle, it means that I can put like other monitoring on top of that. I can do some rate limiting. If I wanted to put authentication on this, I can use Cognito against that application load balancer. I can offload the SSL certificates directly onto load balancer. So there's a myriad of things that become like really easy for me by using this mechanism, though some of that comes at a cost, which is, as we said, like, there's a cost of running that VPN. And I've never looked through my billing to go ahead and see what that cost is. And I don't really want to like open it up now and sort of like skip through it live. But yeah, it was an interesting little project. It was quite fun to go ahead and do. I'll document out the specific relay that I used and the wiring diagrams so that people can follow along if they want to go ahead and do something similar at home. But all in all, like, yeah, it was a fun little project. I'm pleased that many people now are still turning that motor on and off and the lights on and off, and that nothing has fallen over. Maybe I'll quickly add to the stream, and I'll remove the camera.
Yep.
Put the stream. Yeah. Put the terminal in the main window, Matt.
There we go.
So, like, here's that application. Basically, in that virtual environment, I run. It's not running as a service, but it's just using NoHub to run the Flask app in the background, so we can see that running there. If I was to like look at what the application is doing, even though plenty of people are spamming it, we can see that I'm only using a third of the CPU, so the Raspberry Pi isn't struggling. And all in all, I'm guessing the video might be like less than responsive, but I'm saying I've got a feeling that the API itself is pretty responsive. So even all of that network traffic going on and off into my shed, going through 2 Raspberry Pis, using cheap hardware, we still have pretty good performance all the way through.
Everyone else at home playing like Roblox and everything, Minecraft online. So that's like right. You've got a lot of people using the internet, right? It's not just like what we're doing here.
Yeah, my kids are doing school at the moment inside. So yeah, it was a fun little project. I'd love to hear whether people enjoyed having something that they could click on and annoy me with that background noise going on and off. But I thought it was fun, and I think it's like nice to have like something that people can try and see it live and see what happens there.
Perfect. Well, let's wrap up today. We're pretty much nearly exactly on time. And we will expand upon this, right? Like there's some Christmas ideas that we've got. There's bringing in green grass. Like we do want to kind of continuously like evolve and expand this. But I think you've done really good for a couple of days of hacking around on the weekend. So it's a pretty cool solution, and looks like the audience definitely had fun. And you can continue poking it. I'm guessing you're going to leave it up for a little bit longer.
Yeah, sure. I'll leave it up. People can do it. I might just like leave it sitting here running in the shed. It doesn't really bother me. It's not implementing anybody. If I come out the next day and the relay is burnt out, that's okay.
Yep, you've got a smoke detector in your shed anyway. So, anyways, like on that note, let's wrap it up, and we'll catch everyone same time next week. So, thanks for joining.
Thanks all.
Thanks everyone. Bye.
Bye.